Okay.
Hello, this is Aedan and Ahmed Jaheen presenting on our milestone 2 for our project, Arabic language classification, addressing a problem statement. It's Arabic handwriting recognition, and our aim is to address the challenges of character recognition for the Arabic languages using a data set and our proposed enhancements to improve the accuracy and efficiency in the recognition systems. And our chosen model is the GoogleNet model, which was chosen for its pretty much simple, its straightforward architecture and easy to understand updates and user-friendly implementation and efficiency in training. And one of the pluses, it includes minimal file count and use of recent frameworks.
And that's our proposed updates and solution, which is the regularization techniques and learning rate schedule that we done in Milestone and other things that you can see, region transformer, Adapost, and OCR. And that's the progress done in Milestone 1 and 2, where we done the data recommendation and running the baseline model in Milestone 1 and false prediction researching. And okay.
And for milestone 2, we applied label smoothing and focal loss as mechanisms. And then we also tried out JNPL noisy label. And then third, we did a region-based attention and self-attention mechanism in the model. And lastly, we researched OCR techniques to detect the words. And before the updates, our accuracy was 0.2956. And after the augmentation and regularization, we improved it to 0.9481.
Okay, first we researched the label smoothing usage, which did some useful things which prevent overconfidence, which is and overfitting, and it enhanced the generalization, and it introduced uncertainty and discouraged extreme confidence, which it prevents the model from being too certain, and smoothing factor. However, it only works on some architectures. And as we're gonna see in the results, it wasn't that good after adding the label smoothing, which doesn't work good enough on our model. And the accuracy was lower than the original one. And the model was able after that to predict all the classes. So we're gonna experiment with the other noisy label mechanisms.
Yep, and the second is use of focal loss, which targets the class imbalance on the training data, and especially specifically the hard to classify examples. It reduces overfitting to the easy examples, and then enhances attention to difficult cases. Yep, it incorporates a focusing parameter at a time. Yep, and we found that it didn't really improve the accuracy for the most part. So we'll move on to the next one. Bad performance, it was worse than label smoothing. It was able to predict all the classes, but was very low and less than 4% than the original.
And thirdly was the GNPL, which we saw in research paper that was published 3 years ago or something. It's designed to identify and noisy label through a joint learning process that involve filtering the negative learning and improving with clean data with positive learning. And it used unified single stage pipeline with pseudo labeling to make better usage of noisy data. After usage of GNPL, it very improved the accuracy, being 98% with training accuracy up to approximately 100%. And the performance was very, very good compared to other noisy labels. And the model was able to predict all the classes with a very high accuracy of increase of by 3%. And then we are gonna use a different activation mechanism with GNPL.
Oh, and this is results of attention-based, region-based attention, which performed very poorly. So we just didn't. And then the user didn't improve the model at all, and increased the complexity also, and very low accuracy compared to the original. So now we're gonna try a different attention mechanism.
And next was the simple attenuation, the self-attenuation mechanism. We use this as a attenuation layer as the last layer in GoogleNet after editing the GoogleNet architecture. However, the accuracy was so bad. It's like 85%. It's more than region-based, but it was so bad and performed like badly on our model, and it increased the complexity of our model and didn't help at all in improving the performance. So we're gonna use different attenuation mechanism and vision transformers with ensemble classifiers in our next milestones.
Final milestone.
Yeah, and the evaluation update versus our original. We did application of regularization to reduce the overfitting in milestone 1. We did a data augmentation actually in milestone 1, which increased the accuracy. And we done the GNPL, which is a noisy label handling mechanism, and it improved our performance. And finally, we did test the different attenuation mechanism. However, it didn't improve the performance of our model, which is done in this milestone. And next was updates and steps to final milestone.
We're gonna use different vision transformers, try different attention mechanisms, use AdaBoost and different ensemble classifiers, and then use OCR techniques to validate the whole words.
And that's for the member contribution. And thank you.